Welcome to Get XAML. In this video, we'll study the logistic regression. So this is one of the basic classification model. What is logistic regression? To understand this concept, let us understand what we have done in the linear regression. In the linear regression, for example, let us take a given x, the predictors, and then y, the value predicted, and then say there are some data points. What is linear regression? So simple linear regression, we are just fitting a line like this. So we got like beta naught estimate, that is intercept, beta 1 slope, and then our value, x value, that is predictor value. This is simple linear regression. Now let us take a data set is something like this. So let us say y as pass or fail in the exam, and x indicates number of hours of study per week. Let us take this example. So x indicates number of hours of study per week, and y indicates only binary, is pass or fail. Now let us say the data is distributed something like this. Some points here, some points here, like this. Now suppose if I fit a regression line, something like this, so what will happen? So this is not so much of meaningful line, right? So I cannot fit completely the data points. So in that case, what we can do? What is the solution? Solution is simple. So try to fit these points. So that my error is decreased to a nearly perfect fit. So how to do it? So here, what kind of data we have taken? We have taken the outcome is either pass or fail. Okay, true or false. Like, so it's a binary data. So it is 0 or 1, for example. Okay, so pass or fail. So this such kind of things we call it as categorical data. Now to fit the line for categorical data, the simple or any linear regression is not a good fit. It's not feasible because we may have the issues like this. So how will you handle this? If you observe here in this, so let us say zero and then 1 is y, whatever, and x is having some points. Is having some points. Now if I draw a regression line like this, so what it indicates above this, it is greater than 1. So below this, it is less than 0. So if you observe here, our values lies between 0 to 1. So this is nothing but what you can understand it as a probability. So what is that we are finding? We are finding the chances whether it will fail or pass. So this is nothing but the probability 0 to 1. So what is the idea now? The idea here, let's say there are some more points. Here also some more points. Can I stop this regression line here itself? So that means what? How it will look like? This regression line, say this becomes constant here. This is the regression line. What you mean to say here is after 1, there is nothing. Probability can be maximum 1. Below 0, there is no probability. So 0 to 1. So let us try to fit a regression line. Now this line can help us to predict the probability of passing or failing. Right? So that is what you can understand. Now the question is how to fit this function. This is a function. So whatever the function you are seeing here in the green ink, we call it as sigmoid function. Okay, sigmoid function. So what is that you are trying to find here? You are trying to find the conditional probability. Probability of say, y is equal to 1 given x. For given x, you are saying what is it? Y equal to 1. This, let us write as small p. This is given by this sigmoid curve, 1 by 1 plus e power minus z. Now, what is z? Z is nothing but your this regression line. So beta naught plus beta 1 1 plus beta 2 x2 plus so on up to beta p xp. So this is called as logistic regression. So this is the concept. What is the concept here? So when the data is of the type categorical data, so what is that you are doing? So we have the results and the probability, that is between 0 to 1. Now, when I apply the regression, there are many issues here. So we'll see it in the next slide. But let us understand the overall understanding concept here. I have the simple linear regression. We can fit if the data is something like this. But if the data is categorical, so it lies from say 0 to 1, the outcome. Then the data is distributed something like this. Fitting a simple linear regression line doesn't capture all the data. Okay, we need to model this part. Okay, above 1, y above 1 should remain constant. That means if it is above 1, I have to set it to y equal to 1 only. If it is less than 0, I have to set it to y equal to 0, because beyond this there is no meaning. Okay, so now what are the possible issues here? Okay, to fit the regression for the logistic regression, what are the issues? How can we do the logistic regression? So you understood the concept of what is that logistic regression is, but now what are the issues? If you observe, if I take just a regression, the regression values, for example, say this. Okay, so this is taking what, all the real values minus infinity to infinity, right? Belongs to real domain. Now, when I take the logistic part of it, so what is that I'm getting? I'm getting p, the probability value, which is between 0 to 1, right? So now, how will I model this to regression? So that is the question. Hope you are getting it. So how can I do it? So first we calculate the concept called as odds. Odds means it gives us the numerical value, like how many times, okay, I can, how many times what are the chances that he can pass or fail. For example, say that probability that the student passing is 0.8, let us say. So not passing will be 0.2. Now odds is defined as p by 1 minus p. Now p is 0.8 passing, divided by 1 minus p is 0.2. So this is 4. What this indicates? This indicates that the student has 4 times passing compared to failing. Okay, so that is 4 to 1 odds. His odds of passing is 4. That means 4 times he can pass compared to failing 1 time. That is the concept of odds. Now, to observe this value, I have converted into some positive number greater than 1. So the interval p, now it's not anymore in 0, 1. Okay. Now, if you observe this, so what is odds? Odds is given as p by 1 minus p. So this is equal to the previous equation you have seen. So p equal to 1 by 1 plus e minus z. So you already know it. So z equal to your regression line. This is what you are saying. This is the regression line. That is what you are trying to fit. Now, this is nothing but what? To substitute and simplify it, we will get it as e power z. This value is nothing but e power z. If you observe curve, this e power z is always increasing curve, something like this it is. Okay. So now again, this value, whatever I'm getting, is positive always. But for my regression, I need both in the real domain, that is minus infinity to minus infinity. So what is the pictorial meaning? What is the graph meaning here? See, this is my curve. Okay, this is my curve. To fit the linear regression, how can I fit the linear regression? Linear regression should be a straight line, right? This is something what I have to fit. How can I fit this? Okay, if you observe here, let us take this e power z, and then if I apply, let us say this some y equal to e power z. Now if I apply log, we'll get it as log y is equal to z into log to the base e. So that means what you see here, this is nothing but a straight line. This is nothing but a straight line with slope log. Okay. So that is what I'll get the line like this. So you have to convert this odds into log of odds. Log of odds. So that you can take entire domain. This is real domain. So this is also called as logit function. So if I take this log, what will I write? Log of p divided by 1 minus p. This is equal to z, applying to the base e. So this is nothing but a straight line equation. We already know z is equal to in the previous year. So z is my regression line. Beta naught plus beta 1 x1 go on up to beta p xp. So this is the equation for your logistic regression. Is equal to logistic regression. Now, so just to summarize, we had a data like this, categorical data. So let us say x in hours, student studying in hours per week, how it will impact his result. The y is pass or fail. So the maximum is pass or fail. Now, if the data is given like this, okay, so I want to fit the logistic regression. How can I fit logistic regression? Just I am fitting a sigmoid curve, and then this is actually the regression part. So say this, there are some data points here. Okay. 1 or less than equal to 1. So I'm fitting this regression line going till here and then in 1. Okay. That means what? My actual regression can go beyond this. Okay. But the probability values are 0 to 1. So it is not meaningful. So to perform the regression, okay, this 0 to 1 be converted such that it takes the real domain values, that is minus infinity to infinity. So for that reason, we applied the log for the odds. Okay, you calculated the odds as p by 1 minus p, then applied the log, will give you the regression equation. That is how you are done. Okay. So what exactly this means? Suppose a student has say studied 10 hours per week, 20 hours per week, 30 hours per week, 40 hours per week, 50 hours per week. Here to observe in this on this line, the student with say 30 hours is marked somewhere here, and the corresponding y value, that is the probability value, is given. That is nothing but probability means percentage of passing, right? So this value here at this point give us the estimate, or you can also write it as p hat. Now, why did you write like this? Why did you convert like this? Because this is a straight line equation. Okay, so that is the reason this has to match this. Then only the regression is possible. This concept is called as logistic regression. So you have done it using the concept of logit or log odds. So converting this probability to real domain, okay, so that the regression is possible. That is the concept here. Now, similarly, there is another concept like how will you decide the threshold? Means when you will pass or when you will fail. Okay, we can set the threshold. For example, this is my logistic regression curve. Say for example, now if you take this function p is equal to 1 by 1 plus e minus z. This is my regression function. So let us say for z equal to 0. Z equal to 0 means this regression equation will become 0. In that case, what is that I will get? I will get it as p is equal to 1 by 2. So p equal to 1 by 2 means this is 1, this is 0. So p equal to 1 by 2. P equal to 1 by 2 gives me 50%, right? So anyone below this can be considered as fail. Above this can be considered as pass. This is what I can set the threshold. So based on the different regression values, you can set your threshold. What is the pass percent or what is the fail percent? That is the concept here. So this is called as decision boundary. Your threshold you're setting is called decision boundary, because at this boundary only you are calculating whether pass or fail. So that is, if P is greater than or equal to 0.5 or 50%, then you consider it as pass. If P is less than 0.5, you consider it as fail. Any data points, what it means, any data points lying here in this area, okay, are all considered as fail. Any data points in this area are all considered as pass. That is the concept here, because we're getting the boundary here. So this is called as decision boundary analysis. So based on this z value, I can set my threshold. I can increase or I can decrease based on my problem. So let us take an example. You'll understand in a better way. A university wants to predict whether a student will pass. So pass means 1, fail means 0. So it's a categorical data in the final exam. The prediction is based on two input features. So it is dependent on two inputs, that is two predictors. X1 is study hours per week, X2 is attendance percentage. The logistic regression model from the past data is giving us this z is equal to minus 6 plus 0.4 x1 plus 0.06 x2. So what is this? This is beta 1. This is estimate for beta 2. Already they are given. And this is for the intercept. Now, where P presents the probability that a student will pass the course. For a student who studies 10 hours per week and 75% attendance, compute the probability that a student will pass. So it is dependent on two variables, x1, x2. So higher the study hours, higher the passing rate. Higher the attendance, higher the passing rate. So how much they are affecting this regression line? Okay, what is the passing chances? So since it's a categorical data, so they are applying the logistic regression. Logistic regression. So now let us understand these all concepts of odds and all those things that we learned. What is the regression line? So log of p by 1 minus p is equal to my z. That is, they are given it as minus 6 plus 0.4 x1 plus 0.06 x2. Now, how will you find the p? So for x1 is equal to 10 hours per week, they are given here. We are going to predict what is the passing percent. X2 is equal to 75 means 0.75. We substitute that here. So if I substitute it here, I will get minus 6 into 0.4 into 10 plus 0.06 into 2 is 0.75. So we'll get this as log of p by 1 minus p is equal to 2.5. That implies what? P by 1 minus p is equal to, this is base e, right? So I can take it to the power, e power 2.5. This is equal to 12.182. Now you find the probability of passing. How will you find? So p by 1 minus p equal to 12.182. So you can substitute and do it, but you can just write it like this. P, to simplify this equation, what is p here? P is 1 by 1 plus e power minus z. Okay. In if I substitute it in this p by 1 minus p, I will get p as, I can rewrite p as odds. That is p by 1 minus p divided by 1 plus 1 minus p. It is nothing but what? The odds formula, right? Divided by 1 plus odds. So you can directly find it. So I have found out this value. This is nothing but 12.182 divided by 13.182. So I will get this as, okay. 0.924. What that means? It means with probability or chances are 92.4% passing in the exam if he studies for 10 hours per week and if his attendance is 75%. Now, what is the concept of odds here? See, you have got p by 1 minus p is equal to e power 2.5. Now, if you see that beta 1 and beta 2 are given. Beta 1 is given as 0.4. So, odds of this means what? I'll explain. Odds of e power 0.4 out of beta means is equal to 0.4. So, this I will get it as 1.49 or 149%. That means what? If I increase studying 1 hour extra per week, then my passing will increase by 49%. That is the meaning. 149 means 100 plus 49. So if I study 1 hour extra per week, chances that I will pass will be 49% more. That is the concept of odds, how it will help us to find out. Similarly, it is 0.06. So odds of this beta 2, I can write it as E equal to 0.06. This I will get it as 1.062, or you can write it as 106.2%. That means what? Increase in 1% attendance will increase my passing chances by 6%. That is the meaning of this odds. Why we calculate these odds. Okay. So we'll solve many problems in the next video. Please like, subscribe and share. Thank you for watching.